All right, yesterday we looked at how we could determine if a relationship was proportional by looking at a table. Today we're going to look at how can we determine if a relationship is proportional by looking at a graph. Okay? So by the end of the day, you'll be able to review plotting points on a coordinate plane. We're actually only going to spend a brief moment on that, and then you'll be able to determine if a graph is proportional. Now, just as a reminder here is our coordinate plane. This point right in the center, that is called the origin, okay? And then we have ordered pairs, which is our x value first, and then our y coordinate. So our x coordinate, then our y coordinate, meaning that you'll first move left or right, and then you will move up and down. Let's go ahead and take a look at how this works. So if we want to plot -5, 4, I'm going to start at the origin. I'm going to go to -5, 1, 2, 3, 4, 5, and I'm going to go up +4, 1, 2, 3, 4. And right there is -5, 4. Okay, that is that x. Okay, let's plot point y. Start at 0. We're going to go over 2 on the x. Again, that first one represents the x, second one the y, and the y tells me not to go anywhere. So I'm right there, 2, 0. That is our y coordinate. And then finally, let's put point z on there. We're not going to move on the x, right? We stay right here on the x, and we're going to go down 2 on the y. So this is point 0, -2. And we'll put a little z right there. So that's how we plot points on our coordinate plane. Let's get on to the more fun stuff. Now, if you remember yesterday, we looked at a table here and determined if it was proportional or not. We're going to use that knowledge and to see what graphs look like that are proportional, to see what graphs look like that are not proportional, and see if we can come to some conclusion as far as what a graph looks like that is proportional. Now let's first take a look at this table here. We're going to look at all of our data points. Our unit rates. This is y over x, remember. We always want to look at y over x. So this is 3 over 1. This is 6 over 2. This is 9 over 3. This is 12 over 4. Hopefully you recognize that all of these unit rates are going to be the same, which tells us what? That tells us that this is a proportional relationship, right? Since all of our unit rates are the same, then we do have a proportional relationship, and our constant of proportionality is 3. Okay? Now, remember, this table you'll see on the next slide here, we've just shown that this is a proportional relationship. Now we're going to take this relationship, this table, and we're going to graph it on a coordinate plane and see what it looks like. All right, so same table here. And again, this is our x, this is our y. So this is 0.13. This is 0.26, 26. This is 39, 39, and 412. Now, I do not think that they have a straight line tool for me that I can make a rectangle. No. But no straight line. All right, I'll do my best here. So let's go ahead and connect all my lines here. And we see that it is a straight line to connect all those. Okay? So remember, this is a proportional relationship. This table shows a proportional relationship. So this graph shows a proportional relationship. Now, since this is the only one we've looked at so far, we don't really know what characteristics of this graph are determining that this is a proportional relationship. Okay, but keep that in the back of your mind. That's what that looks like. Let's go on to the next one here. And that's what it looked like there, right? Okay, here's another relationship. Let's see if this is proportional. I'm going to skip out on this first one, 0, 0. It's not going to be defined there. So we got 6 over 1, 8 over 2, 9 over 3. And we see that that's 6. This is 4. This is 3, right? Already at that point, we knew it is not proportional. So let's go ahead and graph this table here, which is showing a non-proportional relationship, and see what it looks like. We've just proven that this relationship is not proportional because our unit rates are not the same. So there is no constant of proportionality. Let's go ahead and see what that looks like when we graph this table here. Okay, I'm going to start at this point here, 0, 0. Again, x, y. This is 1, 6, 2, 8, 3, 9. And we see here with this graph here that is not proportional, remember, kind of looks like this. Okay? So in the back of your mind, what's different about this table that is not proportional than the table that was proportional? Right, there it is there. Let me clear this out. There we go. Okay, we'll see these all back here again shortly, all lined up. Now here we have a third table. This is the last table we'll look at. We'll see if this one represents a proportional relationship or not, and see what its graph looks like. Okay, so again, this is our x, this is our y. We want y over x. Again, this is 3 over 0. We're not going to mess with that one because anything divided by 0 is undefined, so just can't really gather much information from that. 6 over 1, that is 6. 9 over 2, that is 4.5. Right there, that's enough information to tell me that this is not a proportional table. This is not a proportional relationship. Let's go ahead and graph this one now and see what it looks like. All right, our first point is 0, 3, 0. We don't go anywhere in the x, and up 3. Then we have 1, 6, 2, 9, 3, 12. Go ahead and connect the dots. La, 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 la. All right. So again, remember, this graph represents a non-proportional relationship. So let's go ahead and take a look at all three of these. All three of these graphs that we just put together here. We knew that this first one was proportional, and this is what a proportional relationship looks like when graphed. And the next two were not proportional. So both of these graphs are non-proportional graphs here. So what can we determine? Just looking at these graphs, how can we determine if we have a proportional relationship? All right, I'm not sure what you said. Normally we'd be a little more interactive with this, but as is the case with me being at home looking after my new son or daughter, I can't be there with you. But here is what we can determine. A graph shows a proportional relationship if, one, it is a straight line and it goes through the origin. So both these things must be true, okay? It must be a straight line and it must go through the origin. Notice this graph here. It's a straight line and it goes through the origin. This graph here, yes, it goes through the origin, but it is not a straight line. This graph is a straight line, but it does not go through the origin. So the only one of these that is proportional that has both those characteristics, a straight line and goes through the origin, is this graph here. Go ahead and let me know, is this first one proportional? Is number 1 proportional? All right. Is number 2 proportional? Now, if you said number 1 is not proportional, you are correct. This is not proportional because it does not go through the origin. Not proportional. Though it is a straight line, right? Yes, it carries one of those characteristics, but it doesn't go through the origin. So it's not proportional. This one, it is a straight line. All right, we got that. And it does go through the origin. So yes, proportional. Let's try the next two here. Go ahead and try number 3. Go ahead and try number 4. All right, looking at number 3 here. Does it start at the origin? Yeah, looking good so far. Is it a straight line? No. Is it proportional? No, not proportional. Number 4 here. Does it start at the origin? Yeah, it does. Looking good. All right. Is it a straight line? No, not proportional. All right. So again, in summary, in order for a graph to show a straight line, it's got to be, to show a proportional relationship, it's got to be a straight line, and it must go through the origin. All right, and then that's kind of an intro as far as it'll be used in a couple other skills that you look at tomorrow. However, for today, I want to just kind of have you work on this IXL skill here. And all we're going to do is determine what is this point S. Well, let's see. How do we get to S there? We are going over 8, which represents goblins. So that's 8 goblins. Okay, this point is 8, and that X represents goblins. And it goes up to 40, right? 40 right there. 8 goblins and 40 power points. Okay, so that's 8 comma 40. Now we need to see which of those represents 8 goblins and 40 power points. So today Rudy defeated 40 goblins and earned 8 power points. No, he didn't. He defeated 8 goblins and earned 40 power points. So this is the right answer here. Okay, that's the winner. Go ahead and see if you can determine which point they're referring to here. All right. So again, let's see what this point is. It's 4 what? 4 cups of pecans or pecans, depending on how you pronounce it, and 16 pralines. Okay, 4 cups of pecans, 16 pralines. Which one is that here? 16 pralines and 4 cups of pecans right there, right? That's the winner. All right. I never made a slide to show what you're working on. Well, it's up here somewhere. All right, there it is. Like magic, I made it appear. So you're working on K10. You only need a SMART score of 80 to get 100%. Go ahead and try that out. 2 other skills pertaining to this type of this concept tomorrow, but we need to go over more stuff. But I didn't want to cram it all into one lesson. So tomorrow, tune in for more graphing fun. Till then, I've had fun. Hopefully you have too. Bye, guys.